Welcome back, dear students. So today we are going to start a very new topic, and the name of the topic is integration by parts. Now, in integration by parts, you have product of two functions, that is f1 and f2. Okay, and here what happens is this product follows some rule. Okay, and that rule is actually known as integration by parts. Now let me quickly write down the rule for you. So rule is, first keep this f1 as it is, integrate the second function, so f2 x dx. Now write negative sign, now put a bracket. Okay, so before that you have to put a bigger integral sign. Now within the bracket you will differentiate the first function. Okay, so differentiation of first function. Okay, now you will again write integral here. You have to integrate the second function dx, and you will close the bracket and again write dx. Okay, so this is the rule. Now how to memorize this rule? The only way of memorizing this rule is by practice. Now you might get confused when the product of two functions is given, which one to be taken the first function, that is f1, and which one to be taken the second function. Now for that you need to memorize this. ILATE, we'll write C also here. Okay, some people or some teacher teach you to follow LIATE, that also fine, or if you want to put C, that is also fine. So whichever one you want to follow, that will be fine. Okay, so let us follow this for now, because I am following this from past so many years. So let me follow this only. Now here I stands for inverse trigonometric function, ITF. This L stands for logarithmic function. Okay, this A stands for algebraic functions. Now algebraic functions means like functions like x to the power n, polynomial and all. Okay, so T stands for trigonometric function. E stands for exponential function. Exponential means a to the power x, e to the power x, etc. And the C stands for constant. Okay, so now okay, I have understood what is I, L, A, T, E and C. Now how to identify which is my first and which is my second function? Okay, so whichever comes in front, okay, whichever comes in front, that will be your function that has to be differentiated. And which function is differentiated here? Here you see that f1 is differentiated, isn't it? So whichever comes first, okay, whichever comes first in this way, that has to be differentiated, or that will be taken as f1 of, or fx, f1 of x. I'm sorry, whichever is coming first from this way, that will be treated as f1. Whichever comes second, that will be treated as f2. For example, if you are given x e to the power x dx, if this is the integral given to you, x belongs to algebraic function and e to the power x belongs to exponential function. Now which one is coming first, A or E? A is coming, isn't it? So that's why A will be treated, or this part will be treated as f1. Okay, f1, and the second one is treated as f2. Okay, let us take one more example. Let me take cos x tan inverse x dx. Okay, suppose if this is my given product, if you see here, cos x is trigonometric function, this is my trigonometric function, trigonometric function, and tan inverse is my inverse trigonometric function. Okay, now which one is coming first in the list? I is coming, so that's why this will be my f1 and this will be my f2. Okay, so with that basic, now let's begin the problems on integration by parts. So let me take the first question. So on the screen you have integrate the following functions. So this is my first question. So you need to integrate this. So let I is equal to integral of x cos x, and we have to write dx also, isn't it? Now let's see, or let me write this here. Now this x belongs to a, right? So this is my a, and cos x belongs to trigonometric, that is t. Now which one is coming first, a or t? We see that a is coming first, isn't it? So that means this is my f1 and this is my f2. Okay, so this is my f1 and this is my f2. So in that way we have to first write f1. So f1 is x, we have to integrate the f2. f2 is cos x dx minus a bigger integral sign, put a bracket, differentiate f1. So f1 is x here, right? Integral f2, that is cos x dx, isn't it? And outside one more dx needs to be put. Okay, so x. Now what is the integral of cos? The integral of cos is sine, so it is sine x minus, now differentiation of x is 1, again integral of sine is cos is sine x, and we have got integral dx outside, so this is x sine x. Okay, so integral of 1 into sine x is sine x dx. Now what is integral of sine x? It is plus cos x, isn't it? So plus cos x with constant of integration. So this is my integration of this particular function. Now let me take another question. So for that, let me do it here only. Okay, so let me take the second question. So second question is x e to the power x. Okay, so let's see how to integrate this function. Now let me take, okay, so let me write let I is equal to x e to the power x dx. Now as usual, this x is algebraic, e to the power x is exponential, a and e. So which one is coming first? A is coming first. So that's why this is my f1, x is my f1, and e to the power x is my f2. So this becomes, okay, so this is my f1 integral of e to the power x dx minus, okay, so we need to differentiate f1, which is x, right? Integral of e to the power x dx, and outside one more dx. Okay, so this is, now pay attention. So x integral of e to the power x is e to the power x itself minus integral sign, so differentiation of x is 1 and integral of e to the power x is e to the power x, outside we have got dx also, right? So this is x e to the power x minus this integral of e to the power x dx, and you know that this is e to the power x itself. So e to the power x, as we are done with the integral, we'll put a constant of integration. So you may pause the video and note it down. Now let me take this question. So here my I is, so let I is integral of x log x dx. So again let me write this here. Okay, so this x is my function a, right? And log belongs to logarithmic function, that is L. Now which one is coming first? L is coming first, isn't it? So log x is my fx, I'm sorry, f1x. So this becomes f1, that is log x integral of f2, that is x dx minus integral of d by dx of f1. f1 is log x, yes, integral of second function, that is x dx, so outside one more dx. Okay, fine. So log x, now integral of x to the power 1 is x square by 2, right? Minus integral of, okay, so differentiation of log x is 1 by x, and we know that integral of x is x square by 2 dx. So you see that x and x gets cancelled, so we have x square by 2 log x minus, so this half can be kept outside, so we have integral x dx. Now again x square by 2 log x minus half. Okay, now how much is this? This is x square by 2, isn't it? Now since we are done with the integral, we'll put a constant of integration out here. So this is okay. So if you want to put x square by 2 common, that will be better. So you have log x here minus you have got half here, okay, plus c. So this is my answer for this particular question. Now let me take another one. Let me take this question. So this is your question number 4. So the question is x to the power n log x. Okay, fine. So let's have a look at this now. So this is my I, isn't it? So let me use another color. So this is my I. So let I equals to integral of x to the power n log x. Do not forget to put dx. Okay, so again this is my A and this is my L. So as usual, A and L means this is my first function and this becomes my second function. So that's why this becomes, so log x integral of x to the power n dx minus integral, so d by dx of log x integral of x to the power n dx and one more dx outside. Okay, so log x to the power n, the integral of x to the power n is x to the power n plus 1 divided by n plus 1 minus, okay, so we have got integral sign first. So we have 1 by, okay, so let me remove this. So differentiation of log x is 1 by x into, this is as usual, x to the power n plus 1 divided by n plus 1, and we have got dx again, isn't it? Okay, so this is again x to the power n plus 1 divided by n plus 1 log x, let me keep it this way, minus, okay, so again 1 by n plus 1 will be kept outside. So you have here x to the power n plus 1 is there, isn't it? So when it goes up becomes minus 1 dx. So 1 and minus 1 gets cancelled. So it's actually integral of x to the power n, isn't it? So we have x to the power n plus 1 divided by n plus 1 log x minus 1 by n plus 1 is already there. Now the integral of x to the power n is again x to the power n plus 1, I'm sorry, divided by n plus 1 with constant of integration. So as usual, I see that this part is common here. So let me keep it common. So you have log x minus 1 by n plus 1 with constant of integration. So you may pause the video and note it down. Okay, now we have sine inverse 2x. So let's integrate this. So here let me write, let I equals to integral of sine inverse 2x. Now let me keep this also ready. Okay, but here one problem is there, you have got only sine inverse 2x. Is this product of two functions? No, only single function is there, right? Now, do I know what is the integral of sine inverse? Again, I don't know that, isn't it? Okay, so if you don't know this, how to do? Can you see the c out here? What is the meaning of c? C means constant, and you know that 1 is also constant, isn't it? So if that is so, then I can put 1 out here. Okay, now this can be considered as product of two functions. This is which kind of function? This is I, isn't it? Inverse trigonometric function. And what is this? 1 is c. Now which one is coming first? You see that I is coming first. So that's why this becomes your f1 and your f2 is 1 here. Okay, fine. So if that is so, let's see how to do this. So as usual, we'll write f1 first, that is sine inverse 2x, integrate the second, that is 1 dx is only dx, okay, minus integral d by dx of sine inverse 2x integral dx outside one more dx. Okay, see here carefully, integral of dx is just x, so we have x sine inverse 2x minus Okay, so be careful here. So the integral of, differentiation of sine inverse theta or sine inverse x. Okay, so derivative of sine inverse x is how much? It is 1 by square root of 1 minus x square, isn't it? So if I put that formula, then we have 1 by square root of 1 minus, and what is x here? In fact, x is 2x, isn't it? So that's why this becomes x square, that is 4x square. Now the chain rule says that we need to differentiate this also. So what is the differentiation of 2x? It is just 2. I hope this thing is clear to you. Now into what is the integral of dx? It is x dx. Okay, now so we have x sine inverse 2x minus, so this is 2x by square root of 1 minus 4x square dx. Now identify this integral. Isn't it integration using substitution? Yes. Okay, so let me call this to be star. Okay, now let 1 minus 4x square is equal to, let me call this to be t. Okay, so in that case, if you differentiate, you will get minus 8x dx is equal to dt, isn't it? Now what do we need actually? We need 2x dx. So calculate what is 2x dx. So 2x dx from here turns out to be minus dt by 4. Check it out. Isn't it true? Okay, yes, this is fine. Now let's go back to our work. So therefore in fact you need not write this star also. So you have integral I equals to, so you are stuck here. So x sine inverse 2x minus integral 2x dx can be written as minus, okay, so let me write it fully. So minus dt by 4 instead of 2x dx. So in the denominator we have square root of, what is this? 1 minus 4x square is t, isn't it? So this is there. So let me do it here, remaining part. So we have I equals to, okay, so x sine inverse 2x integral. Okay, so this minus comes out and becomes plus. So 1 by 4 also comes outside and becomes integral. Only dt is left in the numerator now, and in the denominator we have, okay, so let me bring this to the numerator. So this becomes t to the power minus half dt. All right, so this is x sine inverse 2x plus 1 by 4. Okay, now this is t to the power minus half plus 1 minus half plus 1 with constant of integration, as we are done with the integration. Okay, so we have x sine inverse 2x plus 1 by 4. Now how much is this? This is half, isn't it? Okay, so this becomes t to the power half. Now if I write this division as into, this half becomes 2 by 1 with constant of integration. So you see that this and this gets cancelled. So this is x sine inverse 2x plus, now what is left? Half is there, and square root of t is there, right? So the square root of t, and what is t actually? T is this one. See here, t is this one. So instead of t I am writing 1 minus 4x square. Now is there anything left? No, only c is left. So this is my answer for this particular question. So you may pause the video and note it down. Now let's observe this. Now you have only sec inverse x, again belongs to inverse trigonometric functions, that is I. Okay, so let me write, let I equals to integral of, again 1 into sec inverse x dx. Because you don't know what is the integral of sec inverse, so you have to go for this only. Now as usual, this has to be considered as f1 and 1 has to be considered as f2. So in that case this becomes, so f1 is sec inverse x, integral of second function, that is 1, so it becomes just dx minus integral d by dx of what? Sec inverse x, right, into integral dx, outside also we have to put dx. So this is x sec inverse x minus, okay, so what is the integral of sec inverse? It is 1 by x into x square minus 1. Remember this. Okay. Now here we don't have 2x, 3x and all. We just have x, so you can leave your answer like this. Now what is integral of this? This is just x, isn't it? So we have this integral is done. So this is x. Now we have got one more dx. So this and this gets cancelled. So we have, see here carefully, x sec inverse x minus, so it is dx by square root of x square minus 1. And you know this 1 can be written as 1 square, isn't it? Now, what is the formula for integral of dx by square root of x square minus a square? The formula is, listen to the formula carefully, this is x sec inverse x, let me write it as it is. So this is, the integral of this will be log, okay, so x plus square root of x square minus a square. So what is a square here? A square is this 1. Okay, so as we are done with the integral, only this much is the value for this. Okay, so as we are done with the integral, we'll put a constant of integration. So that's all is my answer for this. Now let me take one more problem. So the question is, question number 7, integrate x, not x, this is just tan inverse of root x. So you want to integrate this now. So let's integrate now. Let me call this to be again, let I is equal to integral. So again inverse, so whenever you see inverse, just put 1. So we have 1 into tan inverse root x dx. Okay, so the rule says this is my f1 and f2 is 1. So this becomes tan inverse root x integral of dx minus okay, so I got my first step here. So this is my f1 and 1 is f2, remember. So this is as usual, integral dx is x. So we have tan inverse root x also minus integral. Now let's see what is the differentiation of tan inverse x. Now the differentiation of tan inverse x is, differentiation of tan inverse x is 1 by 1 plus x square. It's very simple. Okay, now let's apply the same here. So it becomes 1 by 1 plus x square, but here instead of x we have root x, so that's why we have to write root x square. Now the chain rule says, because see, this is not actually x, this is just root x, isn't it? So if this is root x, we have to differentiate root x also. So what is the differentiation of x to the power n? Please do not get confused. Differentiation is n x to the power n minus 1. Okay, integration is other way around. So differentiation is this one. So that's why this is actually x to the power half. So that's why it becomes half into x to the power half minus 1. Okay, into we have got again integral dx, which is x. Outside we have got dx also, remember. Okay, so we don't have space. Let me do it here. Fine. Now this is equal to, we have x tan inverse root x minus, okay, so be careful here. So this is, this half can be kept outside, isn't it? So let me keep this half outside. So this is x to the power minus half, and what is this? X to the power 1. I hope you are understanding what is this. Okay, so what you can do here is, x to the power half minus 1 is already there, right? And what is the power here? It is 1. So you can just add it. Okay, divided by, you have 1 plus square root of x whole square. We'll keep it as it is because you will see soon why am I keeping it like this. Okay, so you see that this and this gets cancelled. So this is x tan inverse root x minus half. Okay, so x to the power half is square root, isn't it? Yes. Okay, so that's why this becomes 1 plus, okay, so this is root x whole square dx. Okay, now here I'm going to do one small substitution. Okay, now let me take let root x is equal to t. In this case I am doing substitution, remember. Okay, so if I take root x equals to t, then from here, now when you differentiate this, no, you will get dx by 2 root x. Okay, so we have differentiated root x. Okay, you have seen that the differentiation of root x was this much, which is exactly 1 by 2 root x. Okay, so the differentiation of x is dx will be equals to dt, isn't it? Okay, but we have root x dx, isn't it? We got the value of only just root x. Okay, but we'll work for this, don't worry. So dx is equal to 2 root x dt, isn't it? So what is actually root x? Root x is t, so that's why this becomes 2t dt. Alright, so let's go back to our work. So therefore your integral I will change into, okay, so this is x tan inverse x, this will remain as it is, minus half. Okay, so pay attention here. Now you see that dx is 2t dt, and what is root x? Root x is t. So this becomes, see here carefully, so 2t, okay, square dt. Now how t is square? This is t, this is 2t dt. Now how much is total? This is t into t is t square, so we have got 2 also, so this is your 2t square dt. So in the denominator you have 1 plus, this is t, right? So this is 1 plus t square. Okay, so this is x tan inverse root x. So you get this 2 outside, so this half will vanish. So remaining is only just t square. So here I am writing this as t square plus 1 minus 1 by 1 plus t square dt. Is this allowed? Yes, definitely. So we have x tan inverse root x minus, now see here carefully, so this is t square plus 1 plus t square dt, minus into minus is plus, so this is dt into 1 is dt by 1 plus t square. Okay, so we have equals to x tan inverse root x. So you see that they gets cancelled, so it's just integral of dt, which is just t, isn't it? Plus, and what is this? The integral of this will be exactly tan inverse t, isn't it? So we can put a constant of integration now. So this is x tan inverse root x minus t. T is root x, isn't it? Plus tan inverse root x plus c. Now it's your choice. If you want to keep tan inverse x common from these two, you can do that, or else you can leave your answer as this much. So you may pause the video and note it down. Let's have this question now. So this question contains whole cube, isn't it? So you see there is a whole cube. So let me write I equals to, so this can be written as x cube log x cube dx. Right? Okay, so let's see how to do this. So this is my algebraic function, this is my logarithmic function. Yes? Okay, so in that case, what you need to do is a and L. Which one is coming? Let's see. So you clearly see that L is coming first. So this is my F1 and this is my F2. Okay, so in that case, we have log x cube integral of x cube dx minus integral differentiation of F2. I'm sorry, F1. This is my F1, remember. So F1 is, okay, so this is log x cube, isn't it? And we have integral, so we have integral x cube dx, and outside we will put one more dx. So integral of x cube will be x to the power 4 by 4. So we have log x cube here minus, okay, so let's differentiate now. So you have to obviously use chain rule because you have got log x cube here. So it becomes, for power it will be 3 log x square. So this is just for power. Now for log x it will be 1 by x, isn't it? Into, so we have got x cube. Now the integration of x cube will be x to the power 4 by 4, isn't it? So we have got dx also. So you see that 3 and 4, that is 3 by 4 will be common or kept outside the integral sign. So we have log x cube here, so minus 3 by 4 will be kept outside, so x and this will get cancelled. So we have x cube log x square dx, right? Now it's going to just stretch, just see, it's going to elongate. X to the power 4 by 4 log x whole square minus 3 by 4. Now again, this is your algebraic, this is your logarithmic, same thing you have to do again, right? So here, okay, so let me do that only. So this has to be differentiated, this has to be integrated. So in that case, this becomes log x square integral of x cube dx minus integral of differentiation of this now. Okay, so let me not put any bracket. So differentiation of log x whole square. Yes, we need to differentiate this. Integral of now x cube, again x cube dx. Yes, so okay, we need to put bracket. You cannot escape from here. Okay, so this is elongating now. You will get one more integration by parts. So this is x to the power 4 by 4 log x square minus 3 by 4. So there's a bracket here. So this is again x to the power 4. I'm sorry, just wait a minute. Here. Yes, this is 3, isn't it? So this is 3. So this will be 3. I'm sorry. So this is by 4. So we'll have log x square minus, okay, so integral. Now again we have got power first, so it will be just 2 log x. Now differentiation of log x will be 1 by x into, again integral of x cube will be x to the power 4 by 4. So we have dx here. Yes, so you see that this and this again gets cancelled, so this is 1 by 2. So you will get from here x to the power 4 by 4 log x cube minus 3 by 4. So we have x to the power 4 by 4 log x square. Okay, so here you see that 1 by 2 is, or it's a constant, so can be kept outside integral sign. So what do we have now? We have x cube log x dx, isn't it? So again we need to put the same thing again here. Let's put, okay, so we have x to the power 4 by 4 log x cube minus 3 by 4. So we have x to the power 4 by 4 log x square minus half. Now here you have to apply integration by parts. Okay, so let's do that. We are almost on the verge of finishing this part. So this is again my algebraic, this is my logarithmic, so this is my f1 and this is my f2. So in that case we will get log x integral of x cube dx minus integral of bigger bracket, that is d by dx of what? The first function is log x. So log x integral x to the power 4 dx. Yes, so we have got dx also. So close the bracket. So we don't have space here. Let me do it in one corner. Let me use another color. Okay, so from here you will write this equal to, so we have, okay, let me write from here only. So this is x to the power 4 by 4 log x cube minus 3 by 4. Open up the bracket. So you have x to the power 4 by 4 log x square minus half log, okay, so this one, how much is this going to be? This is x to the power 4 by 4 log x. Okay, fine. So I'm continuing here. So we have minus sign. So minus, so differentiation of log x is 1 by x, isn't it? So this is just 1 by x. We don't have any power stuffs here. So this is, Just wait a minute. This will be x cube, isn't it? This is x cube, I'm sorry. So this is x cube. So integral of x cube will be again x to the power 4 by 4. Yes, so this integral is done and we have one more dx. Okay, so we need to close the bracket. I'm sorry, there's one more bigger bracket for this. Okay, so we have to put that bracket also here. Okay, so this is equal to, so this will remain x to the power 4 by 4, everything I'm coming from the front only. So this is log x cube minus 3 by 4, x to the power 4 by 4 log x square minus half, so this is there, x to the power 4 by 4 log x. Okay, so you clearly see that this and this gets cancelled, isn't it? So you have minus, okay, so this is written, so minus integral of, okay, so 1 by 4 is kept outside, so you have integral of x cube, isn't it? What is this? It is integral of x cube, and how much is that? That is x to the power 4 by 4. Okay, so are we done with the integral here? Yes, we are done with the integral. So you can put a constant of integration, and here what you can do is you can multiply them, so it becomes 1 by 16, or else if you want to take 1 by 4 common, that also can be done. Now the next simplification part, one more step, these multiplications you will do by yourself. So this will be our answer for this particular question. So pause the video and note it down. So next we have this question. So let me call this to be, let I is equal to integral x sine inverse x by square root of 1 minus x square. Now by seeing this only, I can say that this can be used, or this can be solved by substitution. How? Let's see. So I'm taking, let sine inverse x is equal to t. So if that is so, then from here we see that x is equals to sine t, isn't it? So in this case we see that, see here carefully, when you differentiate this, this will becomes, the differentiation of sine inverse is just 1 by 1 minus x square. Now the differentiation of x will be dx. Okay, so this turns out to be dt. Okay, I'm sorry, I've forgotten dx also. So here this I becomes, see here carefully, this I becomes, so instead of x, see here carefully, this entire thing is how much? This entire thing is dt. Yes, what is sine inverse x? This is t. And what is x? X is sine t. So instead of x I am writing sine t. Okay, instead of sine inverse x I am writing t. So this t can be written in front. Okay, and this whole thing can be written as dt, isn't it? See, this whole thing is dt. So now this is my algebraic function, this is my trigonometric function. Which one is coming first? So we see that algebraic function is coming first, so that's why this will be treated as f1. So this is my f1 and this is going to be my f2. So in that case it's very simple now. So f1 will be kept as it is, integral of f2 sine t dt minus integral d by dt. This time remember the variable is t, so you cannot write dx. Okay, so d by dt of first one, that is t, integral of sine t dt, outside also we need to put dt. Now the work is very simple. So t, the integral of sine is minus cos, isn't it? Minus, so this is equal to 1. So integral of sine is again cos t. So we have got one more integral. So cos t dt is there. So this is minus t cos t. Now the integral of cos is sine t with constant of integration. Now our job is to just substitute the value of t. So it is minus t. T is sine inverse x. I'm sorry, sine inverse t. Yes, this is sine inverse t. I'm sorry, sine inverse x. Now we have cos t also, that is cos of sine inverse t. T is x. plus we have sine inverse t is how much? I'm sorry, sine t. Sine t is exactly x, so that's why this can be written as x with constant of integration. Now there is a formula from inverse trigonometric function for this. Okay, so this will be equal to, so if you refer to your formula book, from there, from inverse trigonometric function chapter, this is equal to, so let me write it here. So this is equals to, so x is written first, minus, so the value of this is square root of 1 minus x square. Okay, but we have got sine inverse x also, so we'll write sine inverse x also. Now we have got plus c left. So this is my answer for this particular question. Okay, now, okay, so you may pause the video and note it down. Now let's continue with this problem. So we have, this is my I, so let I is equal to integral sine inverse x by, okay, so in fact this, you know, this can be written as 1 minus x square, square root of 1 minus x square. Okay, so we'll put dx also. Again, you see that obviously you have to go for substitution. So again, let me do the substitution. Let sine inverse x is equals to t. So from here we see that x is equals to sine t. Okay, so when you differentiate this, you will get that this is dx by square root of 1 minus x square will be equals to dt. Okay, so let's go back to our I. So therefore I becomes sine inverse x is how much? It is just t. Now how much is this? This is dt, right? So dt by, you have 1 minus x square, that is sine square t. So we have got this integral sign. Now you know what is this equal to? This is cos square t. So in fact this, when it goes up, it becomes t sec square t dt. Okay, now as per this rule, t is a, yes, and this is my trigonometric function, that is t. Now which one is coming first? A is coming first, so that's why we have to differentiate t, that is this becomes f1, and we have to integrate, that is this sec square t is my f2. So in that case this becomes t sec integral sec square t dt minus derivative, that is d by dt of t. Remember, integral sec square t dt, one more dt outside. So this is equal to, so this is equal to, now t integral of sec square t is tan t, yes, minus this turns to be 1, so this is integral of this tan t. Okay, so tan t dt. Okay, and we have got, okay, so one more integral is there, isn't it? Now there's a formula, if you remember, integral. Okay, so let me write the formula here. So the integral tan theta will be equals to, so there was a formula from integration using substitution which said that this is equals to log of sec theta. Okay, so this was the formula. So let me put this formula. So this is t tan t minus integral of tan is how much? Log sec theta. And what is theta here? Theta is t, isn't it? Now let's put the value of t. Now we'll put constant of integration also. T is sine inverse x, tan t, t is sine inverse x, okay, minus log sec t, that is sine inverse x plus c. You can leave your answer to be this much. So you may pause the video and note it down. Okay, so let's have this problem now. So here, okay, so let me write, let I equals to integral of log x plus square root of x square plus a square dx. Now, if you pay attention here, you have got only log, isn't it? This is not a product of two functions. So in this case, you will always go for this, isn't it? Now, this is your constant, this is your logarithmic function. So this becomes L becomes your first function, C becomes your second function, right? So this is your first function, that is log x plus square root of x square plus a square. Integral of second function, that is dx only. Now integral differentiation of first, that is d dx of log x plus square root of x square plus a square, okay, into integral of dx. Now one more integral sign. Okay, so this is x log x plus square root of x square plus a square. Now be careful with this differentiation, okay. So we have, see here carefully, first differentiate for log, so it becomes 1 by x, that is this full thing is my x, isn't it? So this is this much. Now as per your chain rule, we need to differentiate this also, so let's differentiate that. So the differentiation of x will be 1. Now the differentiation of this will be half. Okay, so let me directly write it, okay. So this will be in fact 2 square root of x square plus a square, okay. Now chain rule says we need to differentiate this also, so this becomes 2x only. So 2 and 2 gets cancelled, into we have got integral of dx will be x. Now we have got dx also. Be careful with this calculation, okay. So we have x log x plus square root of x square plus a square. Okay, so let's simplify this. Now if you see here carefully, this becomes, so we don't have, this is just x by square root of x square plus a square, okay. So when you simplify this, this will come here, this becomes x square plus a square plus x divided by, we have square root of x square plus a square. Now this is the simplification of numerator only. Now this line is what? This is into, isn't it? When it converts into multiplication, this is division. When it converts into multiplication, this becomes 1 by x plus square root of x square plus a square. But remember we have got x also, so that x will be kept here, okay, fine. So you see that this and this both are same, so they will get cancelled. So we have x log x plus square root of x square plus a square minus, so this is x dx by square root of x square plus a square, right. Now this is your integration by substitution. So let x square plus a square is equal to t. So from here you see that 2x dx will be equals to dt, that is x dx will be dt by 2. So therefore your integral I will change into x, so this will be kept as it is. So x plus square root of x square plus a square minus, so you know that x dx is half dt, so this half will be kept outside. So we have dt. Now what is this? Square root of t. Now what is the 1 by square root of t can be written as t to the power minus half, isn't it? Yes. So in that case, okay, so in that case we have, this is the continuation, please remember. So this is x log x plus square root of x square plus a square minus half. Now the integration of t to the power half will be, t to the power minus half will be this much, yes. Okay, so as we are done with the integration, we will put constant of integration. What is this equal to? This is equal to half, isn't it? So this half and half gets cancelled. So this is x log x plus square root of x square plus a square minus, now t to the power half is square root of t, and what is t? T is x square plus a square. We'll put a constant of integration. So you just pause the video and note it down. Okay, now this question, again you see that there has to be some substitution being done here. We have to do, And the substitution that you can make here is log x is equal to t. So from here you see that log x, differentiation. When you do differentiation, you will find that this will be dx by x equals to dt. So here this becomes dt. So we get, so therefore your I becomes integral log, now log x is t. So that's why this becomes, this entire thing is actually log t, and dx by x is dt. Yes, now this is a single function and you don't know how to integrate logarithmic function. So for that you will put 1 here. Okay, now you have to consider log, see, because 1 is constant which comes at last, so that's why this has to be integrated. That is, this is my second function, so this becomes my first function. So that's why this is log t integral dt minus integral of derivative, that is d by dt of log t. Yes, so log t into integral of dt. So outside we have dt again. Okay, so this becomes t log t minus, this is 1. So this is actually, no, I'm sorry, this is not 1, this is 1 by t. So this is integral 1 by t into, now what is this? This is t. So we have got dt. So t and t gets cancelled. So we have t log t minus, now integral of t, integral of dt is t with constant of integration, as we are done with integration. So we have t. What is t actually? T is log x, isn't it? So this is log x into log of t. Now t is again log x. Okay, minus t, that is log x, plus c. If you want to take log x common, that also can be done. So log x is common, so we have log of log x minus 1 plus constant of integration. So you may pause the video and note it down. Okay, so let me take this question. So here, now let me call this to be, so let I is equal to tan inverse square root of 1 minus x by 1 plus x dx. Okay, now as usual, if you want to put 1, that also can be done. Now if that will be done, if that is done, if I put 1 here, then this is my c. So that's why this becomes my second function. So this becomes my first function. Now you know that the first function will be differentiated. Now if I ask you what will be the differentiation of this, now this is going to be a bigger problem for you, isn't it? Because first you will differentiate for tan inverse, that's okay. Now you have square root of this, now you will do for square root, now for, and after that you will do for this, that is u by v form. So it's going to be a huge task for you. Now whenever you have such kind of cases, what you do here is you have to do substitution. Now you have to substitute in such a way that you have got tan inverse here, isn't it? So this becomes tan theta. That's what you have to search for. So basically if you want to substitute here, basically you are substituting the value of x, isn't it? Now if I put x equals to cos 2 theta, let's see what happens. So let x is equals to cos 2 theta. So in that case we need to find what is the value of x also. So first let's differentiate. Okay, so differentiation gives me dx equals to minus 2 sine 2 theta d theta, isn't it? And we need to calculate what is x theta also. So it becomes half of cos inverse x. Remember this. Okay, fine. Now let's go back to our work. So therefore I becomes integral tan inverse of square root of 1 minus x, x is cos 2 theta, yes, divided by 1 plus cos 2 theta. Okay, now this is for this part, the circle part. Now you have got dx, and what is dx? Dx is minus 2 sine theta, isn't it? So minus 2 sine 2 theta d theta. This is the value of dx. Now you see that minus 2 is a constant, can be kept outside. So this is okay. Now can you tell me what is this equal to? From class 11 trigonometry you must be knowing that this is equals to, so root over this entire thing is tan square theta. Please refer to your half angle formula from class 11. Okay, so minus 2 is gone outside, so we have sine 2 theta d theta here. Okay, so minus 2, we have this tan inverse, this is what is this, isn't it tan theta? Yes, so we have sine 2 theta d theta. Now see here, this tan inverse and tan gets vanished and you will get only theta here. So theta sine 2 theta d theta. Now will you be able to do this? Definitely. So this is your algebraic function, this is your trigonometric functions. Do the needful. At last substitute the value of theta to be this much. That will be your answer. Okay, so one more question will be there. I am giving you one more hint for one more problem. So your problem is, okay, so where is my pen? Okay, so your problem is, so this is my 14th, isn't it? So 14th problem is sine inverse square root of x plus a plus x. Okay, so this is my problem here. Now here you need to choose one x in such a way that this entire thing, okay, so let me use another color. So this entire thing becomes sine inverse, sine theta. Okay, as I want to make this sine, okay, so basically whatever is there within square root sine, I want to make it sine square theta, isn't it? Now how to make it sine square theta? For what value of x will this entire thing will become sine square theta? For that you can do this kind of calculation. See here carefully. So x by a plus x has to be sine square theta. Yes, and you want to find what is the value of x. So you do the cross multiplication. So this becomes x into a sine square theta plus x sine square theta. So this goes over there because you want to find the value of x, remember. So the x will be, okay, x will be common, so you'll get 1 minus sine square theta equals to a sine square theta. Now how much is this? Cos square theta. So from here you'll find that x will be equals to a sine square theta by, okay, so this cos square theta goes over there in the denominator, so becomes a tan square theta. So this is the substitution that has to be done, but this has to be done in the rough work, remember. Okay, so let's go back to our work. So let x is equal to a tan square theta. Okay, so now our job is to differentiate. Okay, so this is my, remember, okay, so this is my integral I. So I is equal to integral this much. Yes, let's find the value of dx. So for that we need to differentiate this one. So let's differentiate. So you will get dx is equals to a 2 tan theta. Now this is for power. For tan theta, what is the differentiation of tan? It is sec square theta. Remember this. Okay, fine. So this is my dx, remember. Okay, now go back to our work. So I is equal to, okay, sine inverse. Now substitute the value of x to be a tan square theta. Okay, so we have a plus a tan square theta into dx is, okay, so this entire thing is my dx. So we have 2a tan theta sec square theta d theta. Okay, now you know, see this full thing turns out to be sine square theta. So square root of sine square theta will be sine theta. Please verify. Okay, verify, you will definitely get that. So this entire thing, this bigger circle will give me theta. So this 2a is constant, will be kept outside. So this entire thing is theta. So tan theta, now you know that the sec square theta can be written as 1 plus tan square theta d theta. Okay, now 2a, now let me make two different integrals out here. So one will be theta tan theta into one is theta tan theta d theta, okay, plus now another is, okay, we have theta tan theta into tan square theta is theta tan cube theta, remember, okay. So we have d theta also. See, this is one integral, this is another integral. So there are two integrals that has to be evaluated. You call this as I1, you call this as I2. Find the value of them separately. Ultimately, substitute the value of theta from here. So the value of theta from here turns out to be theta is equals to tan inverse of square root of x by a. Okay, so that's what you need to substitute at the end. So with this, we close for the day. Thank you very much.